Here is my witch's cackle. Yeah. Thanks for watching 3.2. Your host, Mr. New Bold. Let's go. So we're helping you on 3.2 here, right? So don't forget PEMDAS. 3 times 3 times 3 is 27. 3 times 3. Oh, pause me. You already started just copying it down. What are you doing? You got to pause me. And try it on your own first. Each problem, try it on your own. 3 squared is 9 plus 5. So then we got 9 plus 5, 10, 11, 12, 13, 14. So what's 27 minus 14? Is that 13? I think that's 13. Way-o. Here we go. Solve for t. Add 2r to the other side, and then divide by 5. Way-o. Keep on trying your best. Keep on trying your best on these problems. Number 4, 5, and 6 is more review from Unit 1. So keep on reviewing, right? Keep on reviewing. Pull out a square root of maybe a 2 and possibly a 9. And then don't forget all your pairs, right? Don't forget all your pairs. So you've got lots of m's going on. And lots of m's on the bottom to cancel. Write them all out. That's the easiest way. Write them all out. This one we're going to cancel with one on the bottom, so that brings it to the 8th. Save you a little bit of writing there. Number 7 and 9. Don't forget how to factor. You remember how to factor? You got to remember how to factor. Remember the special difference of squares. X and X. What are factors of 9? Perfect squares. That's right. 3 times 3. What's a 64? Pause me. Pause me. 64 breaks down into the square root of 64, which is 8. So 8 times 8. A plus and a minus because it's called difference of squares. Right? Don't forget to factor this one and this one. We're going to pull out a GCF first. Pull out a 3x first. We're going to pull a 3x first out there. Good. Now you're probably going to have to factor more. Don't forget, factor more. 15 divided by 3 is a 5. You have your x there. Plus the x's cancel. 18 divided by 3 is 6. So that could be a 2 and a 3 or a 1 and a 6. I'll let you decide. Make sure you factor more. Make sure you factor more. Okay, so determine whether each graph represents a polynomial or not. So remember that we learned that polynomials are smooth and continuous, okay? And since number 11 is smooth and continuous, and don't forget the domain and range. So the polynomial for domain and range, do you remember? For domain and range are negative infinity, positive infinity. Don't forget to pause me. Stop, don't copy. Just pause me so you can try it on your own. And then push play and see if you got it right or not. Pause me. So yeah, so this is certainly explain your reasoning because it's smooth and continuous and the domain is negative infinity, positive infinity. Yes, it is a polynomial. So determine whether each graph represents a polynomial or not. So yes, it does. Yes, it does. Poly, it does. Poly, yes, it does. Polynomial. Now, because this one has a piecewise function, that means it's not continuous. And that means it breaks off into 2 different graphs. And 2 different graphs means piecewise. Because one's a straight line going down and one's a parabola going up. So not continuous and not a polynomial. Polynomial. What about this one? Yeah, this looks kind of like the square root, opposite what you think, so minus 2. It's like a square root going up and to the right. Something like that. So is that a polynomial? Is that a polynomial? Is it continuous? Is it negative infinity, positive infinity? No, it goes from 2 to infinity, right? It goes from 2, x equals 2 to x equals infinity. Yeah, so not a polynomial. Not a poly. Okay, so this one's really good for matching purposes, right? So we'll let you try this one on your own. Don't forget, don't get tricked up here. So this one is just a line. In fact, it's a negative sloping line, right? Yeah, it's going like down 2. This is A. So down 2 over 1. Can you find a sloping line that's down 2 over 1? Maybe this one is down 2 over 1, down 2 over 1. Well, so this first one will be F. And so just kind of look for clues, right? Look and see if it gives you the y-intercept by chance. Maybe that could help you, maybe not. Look how many times it crosses the x-axis. 1, 2, 3, 4, 5 times. Wow, that's a lot of x-intercepts there, isn't it? This is an upside down parabola. Upside down parabola, this is like a negative x cubed, right? So kind of look at the fine details, and you'd be like a detective. Be a detective when you're looking at each of these multiple choice, and see if you can figure out without using the calculator. Be a detective. And use clues. Whoa. Use clues in there to help you. The x-intercepts, how many of them are there? That matches with your power, right? If it's x squared, it's got 2. X to the third power's got 3, right? Is it going end behavior? Look at the end behavior. Look at the end behavior. And looking at the end behavior, looking at the leading coefficient as well as the degrees will definitely help you. So thanks for looking at that. Okay, show the end behavior using directed arrows. Okay, that sounds easier than the way I taught it in class, which is fine. It's fine. A little lazy there. It's okay. So this is x to the 4th power. So that's, and this is a positive 2. And since it's a positive x to the even power, that means our end behavior is going to go up, up. Whoa, up, up. Now really, up, up is actually supposed to be written as, right? As x goes to the right, positive infinity, y goes up. And as x goes to the left, negative infinity, y goes up. But if we're being lazy, then we're just going to do up, up. So give that a try. Maybe distribute this through first. Number 17, divided by 4. Well, the highest power is still 7. And you do have 3/4, x to the 7th power, which is positive. Way-oh. Does that look like this? Or does it look like this? Which one? Which one is it? Well, it's odd, so definitely it's going to be one of those two. And it's positive in the front. So if it's positive in the front, it should go down to up. So it should be this one right here. Let's take a look. I won't type the whole thing in, but we'll just try that end behavior there. So 3/4, whoa. So 3 divided by 4 to the 7th power. Yeah, why don't you type it all in, Nebo? Okay, I will type it all in. Fine, I'll type it all in. Fine, you want me to? I will. Plus 5. Oh, but they're all fourths is the problem. What the? Does that matter? I hope not. Maybe it matters. Oh man, I don't want to do all fourths. Lame. Okay, well let's try it this way then. 3x to the 7th power, right? If I put it all in parentheses and get away with it, so 2x to the 5th power, good, plus 5x to the 3rd power, plus 6x squared, close parenthesis, all divided by 4. Ha! I did it! Let's see what that looks like. Whoa, look at that one. So it is like that one. So it goes down, and then it goes up. Whee-oh. Just as we said, down then up. Okay, we're on number 19 next. First, let's see how long our video is. Should we do another one? Let's do another one. We'll stop it here for now. And do another one. Thanks for watching. See you in a second.